Coordinate systems are very important to solve physics problems. Here we will look at two types of coordinate systems. A coordinate system is used to specify the position of a point in space, and a coordinate system needs to have a reference point called the origin, and then it needs to have a specific axis and labels. There has to be instructions on how to label a point in this system basically. The most common form of coordinate system that is used is the Cartesian coordinate system as shown in this figure. So it is represented by distances along the x-axis and the y-axis. It's given by two numbers x, y. Any point can be labeled as a pair of numbers x and y, for example. And then another form of coordinate system is the polar coordinate system. This also has two numbers in two dimensions. One is called r, and the other is denoted as theta. R represents the shortest distance from the origin to a particular point, and theta represents the angle r makes above the horizon basically. So we can easily convert between these two coordinate systems. For example, if you are given your coordinates in r theta, it is easy to find the corresponding x and y in the Cartesian coordinate system. This can be done by making use of the right triangle as shown in this figure. So r is just the diagonal, the hypotenuse of this right triangle, and x1 is the adjacent and y1 is the opposite side basically. So you can easily define sine theta, cos theta, and tan theta of this triangle. And so your x coordinate x1 is given as r cosine of theta, and y1 is given as r times sine of theta. We can also go the other way. So if you are given the Cartesian coordinates, we can easily find the polar coordinates. For example, the polar coordinate, the theta is given by just the tan inverse of y over x, and r is given by square root of x square plus y square using this right triangle. And here is an example. You are given a Cartesian coordinate. You have to find the polar coordinates, and we use Pythagoras theorem to evaluate the r, the hypotenuse of this right triangle. And then for theta, we use tan inverse y over x as we have seen in the last slide.